Hello, welcome back to our intro to the C programming language. This is session number 6 of 10. If a quick recap of the previous session, we went into the nitty-gritty of how macros work and why you probably shouldn't be using them all that much. This time we're going to be going into detail about how arrays work. We've seen arrays before, but we kind of glossed over them, and I kind of just left you to play with them on your own. This time we'll be properly going into detail with them. So, again, we've seen them before, but just to make sure that the definition is fresh in your mind, an array is a chunk of memory that is dedicated to holding a whole bunch of the same kind of data. In particular, arrays are fixed size, so an array can neither grow nor shrink. Arrays have to all be of the same type, so you can't have an array where the first element is an int, the next is a double, the third is a character, the fourth is a pointer, etc. And arrays are generally used to give collections of data a name, as opposed to giving each individual part of that collection a similar name. This also allows this also allows the programmer to iterate through sets of elements of data in an array, using variables or using what are they called? Literals. Sorry. We've seen me declare arrays before, but just another quick refresher. The name of the data type, space, the name of the array. This space is actually unnecessary here, but can be used for style. An open square bracket, the size of the array, and a closed square bracket. This can be a literal, this can be a variable, but there are some caveats to using variables to declare the size of an array. This slide here says that this is called a single-dimensional array, but under the hood, all arrays are single-dimensional. You can have arrays of arrays, and those are often treated as though they are one contiguous set of they're often treated as one multi-dimensional array, but under the hood they're just arrays of arrays. Here we see a quick example where we have an array of 10 doubles. In order to read more complicated declarations like this, there exists something called the right-left rule, where starting from the name of the variable, you go right until you can't, and then you go left until you reach basically a set of parentheses, and then you bounce right and left, and so forth. I don't think we go into any detail with that in this course. It's kind of an advanced thing, but it's something that you can look up yourself if you are curious about how that works. But following the right-left rule will give you a clear idea of what any particular variable is if you're having trouble reading the declaration or definition. So, initializing an array. You can initialize arrays in a couple of different ways. The first way is to use a set of curly braces. Inside the curly braces, you list out the values that you want to be in the array in order, separated by commas and spaces, like so. Actually, they don't have to be separated by spaces. The commas are sufficient. But the spaces are used to make it, readable to humans. The number of values between these braces cannot be larger than the number of elements in the array. If you decide not to explicitly state the size of the array, you do have to initialize it, and the compiler will give you exactly enough data to hold all of the elements that you list. So in this case, the compiler will say, okay, I see you want to make an array of doubles. You haven't told me how big it is, so I'm going to look into this initializer list here, and I see 1, 2, 3, 4, 5 doubles. Cool, I'm going to give you, that's what, 8 times 5, so 40 bytes of data. for this array. And you can also assign to each element of an array individually using the subscripting operator, which is these square brackets here. So the square brackets are used both to declare an array and to access what is in an array later. We've seen diagrams like this before, but again, just quick refresher. We have a contiguous chunk of data here, enough to hold these 5 doubles. We list them in order, so we've got 1000, 2, 3.4, 7, and 50. And they're listed, they're numbered from 0 to 4. The first index of an array is always 0. And I am pretty sure I mentioned this in the lecture about pointers, but that's because arrays are pointer arithmetic under the hood. Whenever you're using an array, what the compiler says is take the address of the first element of this array and then add to it whatever is between the square brackets. So when you say array sub 0, the compiler reads the address of the first element in this array plus 0, which leads you to the first element. Addressing elements. Here we see an example of using the address, of using array addressing or array accessing to by using a variable to do it instead of a literal. In this loop here, we just go from 0 to 9, seeing how we have 10 elements in the array. We go from 0 to 9 and set each individual element to the array to I plus 100. If this looks a little confusing to you, feel free to skip ahead to the 10th lecture in the series. That'll be the last one, and that's the one where we go into detail about control structures like this for, if, while, etc. It might feel a little weird to do this in this order, but things all kind of... It's hard to find a particular order to teach things in C. Once it clicks, it all kind of just meshes together, and until it does, you kind of just have to pick orders to introduce things arbitrarily, more or less. So yeah, feel free to skip around, and feel free to go back and review if you need to. Stepping through an array, we see another example of using a for loop to essentially walk through every element of an array. In this case, we actually do it with a multi-dimensional array, or an array of arrays, using 2 nested for loops. We also see here that you can use a variable to name the size of the array. But if we look down here, we see that there is a caveat here. When you use a variable to make an array, you can't initialize it. This is because the size of that array isn't known at compile time. The compiler can't write code that will say for sure how much data needs to be allocated for that array. Essentially, it has to call something close to malloc under the hood. It's not exactly malloc, but it's pretty close. Let's see, was there anything else I needed to go over with that? I don't think so. I have an example of this in my Scratch sheet, that the source code to which will be uploaded to the site, and towards the end of the lecture I will go over the example code I wrote. We'll compile it, we'll run it, and we'll see exactly what it does. Arrays of pointers. As I mentioned earlier, arrays can store any data type, and sometimes you'll want a collection of pointers. This might even be an array of pointers to other arrays, or it might be arrays of pointers to individual ints, or even a mixture of them because they're the same data type under the hood. So this is how you declare an array of pointers. Just int pointer, name the data type, and you tell the compiler that it's an array. We have some sample code here. So we declare var as an array of ints. We have I as a looping variable, and we have a array of pointers to int named pointer with that is 3 elements wide. We see max declared up here, or defined up here. Then we walk through it. We assign each of the pointers in PTR to the address of a variable in var. So essentially, each element of PTR now points to the corresponding element of var. And the printf statement down here will show that to be true. We can dereference the pointers as we access them using the subscripting operator. Arrays of strings. Remember under the hood that strings are arrays of characters, with an extra space for a null character at the end. So similarly to how we make arrays of int pointers over here, we can make arrays of strings using arrays of constant character pointers. And we have an example here. So we have an array of strings here, so each individual element says hello world C is easy, but under the hood these are just pointers to character arrays. Passing arrays to functions. Fairly often you find yourself wanting to send an array over to a function, which is lovely and all, but C doesn't make that easy on you necessarily. There are 3 ways to try to pass an array over to a function in C. The first is by passing a pointer to the array. The second is by formally telling the compiler how big you expect that array to be. And the last is by just saying it's a generic array with no fixed size. The issue with this is that these second 2 ways are lying to you. When the compiler reads these, it says, oh cool, you're passing a pointer to an int, or you're passing a pointer to whatever data type. These 2 ways of having arrays as parameters to functions all instantly get turned into pointers to those arrays. This is for a handful of reasons. One is because in C, arrays are what's called a second-class citizen. Arrays are not given the same abilities that things like ints or floats or characters are. For example, you cannot assign one array to another. You have to individually step through the array and assign them, and assign each element one at a time. You cannot, I'm struggling to think of another example that isn't pass them as a parameter to a function, but, you know, here they are. So, the second reason why you wouldn't be able to pass an array as a parameter to a function is that we've seen before how parameters to functions are passed by value, which means that a copy of them is made and passed along to the function instead of the original piece of memory getting referred to, unless you're using pointers. And this would cause a lot of overhead. The runtime would have to allocate all new memory. It would have to copy whatever's in the current array into the copy of the array, pass that along, and then basically just throw that memory away when it was done with it. It'd be a waste of memory, it'd be a waste of processor time, and ultimately it would slow C down as a language pretty heavily. So instead, they just decided, nope, you can't do that. If you want to pass an array, you have to pass a pointer to it. If we move on a little bit here, under the hood, all of them produce the same result. We just went over this. Any information about the array is lost when you try to pass it like this, and because of this, you have to have another parameter that is the size of the array if you want to be able to index into that array safely. And so if you walked through this, you would check that you're not going outside of the size of the array. We see an example of this right here. Let's see. This function here just takes an array of ints, and you have to tell it the size of the array, and it will add all of the elements in that array up and divide by the size to return the average of the elements in the array. A couple of notes on dynamic memory allocation. We've seen previously that malloc takes in an arbitrary quantity of bytes to allocate. Because of this, we can allocate arrays using malloc. We just multiply the size of the data we need times the number of elements we want in the array, and malloc will give us one contiguous chunk of that size. When you're freeing memory, you do not need to worry about how much memory needs to be freed. The operating system keeps track of how much memory it passes and the pointers related to those for you. If you were thinking about this, it is good because something similar to this does come up in C++ in the form of because C++ handles memory allocation in a different way to C, even though you can use the C method if you really want to. And because I couldn't find another place to squeeze this in, but this is a really fun fact to me, because arrays are all pointer arithmetic under the hood, you can make C do some really weird things with them. For example, there are 3 ways here to index into an array. You can have array sub 4 equals 2. This is the normal way to accomplish something like this. You can have 0 sub array plus 4, and what this does is, starting from address 0, I want to grab whatever is at the address of the array plus 4 times however big the data in that array is. Again, it's really clunky, it's really hard to read, and you should never actually do this in code you care about other people being able to read. And a similar effect is gotten by saying, starting from address 4, add the address of the array equals 2. Please, never actually use these bottom 2. This is an interesting little bit of trivia. So, multi-dimensional arrays. I mentioned earlier that arrays are all one-dimensional. However, you can have arrays of arrays. And you declare this in a pretty intuitive fashion. You have you tell the compiler how big the first array is. Or it can be a little unintuitive. It depends on how you choose to read it. So the first thing you do is you tell the compiler how big one dimension of the array is, and then you tell it how big the other dimension of the array is. The strictly more accurate way to read this is, the first thing you do is you give it the data type, the name of the array, and you tell it how big each individual array in the array of arrays is. And then you tell it how many arrays of this first size are in the larger collection. Again, it can take some practice to get used to reading things like this, but it will solidify the idea in your mind of what is actually going on when you tell the computer to do certain things. Similarly to how you access other arrays, you can use the subscripting operator twice. I can't point down there and it bothers me. So I'll just point in the general direction and wait for the thing to fade. Come on, quick as you like. No? There we go. So we would access column 2, row 0 by having a sub 0 sub 2, or a brackets 0 brackets 2. This is held in row major order, if I recall the naming convention correctly. And that means that rows are held together in memory and columns are separated in memory. So each individual array of this list of arrays is one row of this matrix here. Initializing two-dimensional arrays. If you remember how we initialized arrays before, this is a pretty simple extension of it, where you can start initializing one array and then initialize the other arrays as smaller, as using the same syntax, separated by commas. So you can see the example here. We want one 4-element array of 0, 1, 2, 3, then 4, 5, 6, 7, and then 8, 9, 10, 11. Let's see here. The nested braces are optional because arrays are all contiguous in memory, meaning that essentially you are being given one long array that you get to treat like more than one. So doing it all at once like this is also perfectly valid. Accessing two-dimensional arrays, we actually went over that in the last slide, so I'll give you a moment to read this to double check, but I don't see a reason to repeat myself. So, instead of going into a summary here over things we've heard already, I'm actually going to Alt-Tab into my Scratch sheet, and we're going to look at this code ourselves. So I have included standard.io.h and string.h because I'm going to be doing some string trickery. Here is the dump array function that we have seen earlier, and let's go into main here. Array 1 is an array of 5 ints that I set them all to 0. I set them all to 0 by setting the first element to 0 and then letting the C compiler do what it does and assume that because I didn't list all the rest of them, 0 is fine. I have a size here, and so I have array 2 be an array of count ints, and I can define count as any integer. I have hello is a pointer to characters that are constant. So a string, and it says hello world. I get the length of hello world here. And I have an empty array of characters here that is long enough to hold hello world plus the null character. And so we'll be seeing the one of the potential pitfalls of using a variable to make an array in a moment. So first thing we do, we set the last element of array 1 to 5, and we dump array 1 to the screen, and then without doing anything to array 2, we dump it to the screen. Real quick, let's clear this. GCC star.c session6.exe. Again, this just takes all of that's the wrong character. Again, this just takes all of the .c files in this directory, and this tells GCC that I wanted to output the file named session6.exe. So compile this, works just fine. We can see that everything in array 1 is 0 until we set the last element to 5 here, but in array 2 we have random garbage in here. So when you get an array of a variable size, or you get it as is, just like when you're allocating heap memory. We'll go into everything this does in just a moment. So down here, we print hello copy before we do anything to it, and this is used to prove that that this character array will decay into a character pointer under the hood. So we're just passing this along as a character pointer. Similarly, we're copying the string hello world into this array over here and printing it again. We see here that the first time we print hello copy, It's, again, filled with random garbage. We just got whatever was already there when we started. And in fact, judging by how my... No, that was incorrect. I was thinking that because my terminal let me select things from here, that we were actually getting a handful of invisible characters here, but that was incorrect because I can do that from anywhere on this terminal. I'm just used to other terminal emulators. Then the second time we get Hello World just fine. These last 3 lines right here are examples of that crazy array subscripting syntax that I showed you in one of the later slides. So here we get the third element of hello copy, or the second if you want to say the first, the element at the beginning of the array is the 0th one. Either way, we get the first L in hello world. Here we get the first L in hello world in a different way by... that's not right. By starting from address number 2 and then adding the address of hello copy to it. And the third time we do it by starting at address 0 and adding hello copy plus 2 to it. This is just proof that I'm not screwing with you. These 2 syntaxes are actually valid. Just never use them, please. And here is another chance to review the output. And in case you forgot, GCC star.c-o name of program. This source file will be uploaded to the website and should be accessible from the same page that this video is on. Before we go, next session we will be demystifying that printf function I've been using so much, going into how characters are encoded in C, dealing with standard inputs and outputs, among a handful of other things that are important to getting out the output you want onto your terminal screen. As always, there are private coaching sessions for software design and engineering, and C and C++, among other languages, available on this very site. Thank you for joining us.